So now this video discusses on how we can add two or more vectors using the component method, and of which we have several ways in which the result vector can be obtained. And last time we talked about using what we call as the graph method. So we can be able to add two or more vectors using the graph method, and of which the graph method, it consists with what we call as the triangular rule, that is the triangle rule, and we have also what we call as the parallelogram rule, that is also another method under graph method. And we also talked about the polygon rule, so that is also another method in which we can use to add two or more vectors under graph method. And apart from the graph method, we also talked about the geometric method. So we can be able to add two or more vectors geometry. On the geometry, we have the likes of the sine law. So we talked about the sine law, and we also have what we call as the cosine law. So these laws are the fundamentals behind the geometric method of adding vectors. But also on the case of the graph method, we also have the primary formula. Actually, we also have the primary, that should be on the geometric method. We also have the primary aspect, which is what we call as scale drawing. So geometric method, at some cases, if we are not using the sine law and also the cosine law, we can think of using the scale drawing. It can work as well. But apart from all this, we also have another method, and which is known as the component method. So what is the component method of adding vectors, and what are its working principles behind? And assuming that we have two vectors, let's say we have a vector A with its components, which is given as ax, should be I, plus let's say we have the x components, should be the components of vector A, which is given as axi, and let's say we have ayj. Let's say that is the case, and we have another vector, let's say vector B, with the x component, which is bxi, and plus let's say byj, like that. And now, what is the summation of these actually two vectors, or actually componentry? So let's say the summation of these two vectors should be given as the resultant. Then we'll have it as the resultant vector. So at the end of the day, you have to understand that the resultant vector, which is R, is equal to the vector, of course it is given as the vector A plus that of vector B, as you can see. And also in the same case, you should have to understand that since all these vectors are having their own components, then also you should have to bear in mind that the resultant vector, which is vector R, should also have its components. We'll have rxi, that is x component, and we'll have ryj, that is y component. And what is x component of the resultant vector? Now the x component, which is rj, so the x component, which is rj, consists of the x component for the vector A plus the x component for the vector B. And also in the same case, the r actually yj, and for the resultant is given as y component of the vector A plus the y component of the should be a vector B. So have it as that. So in this case, what it means is that now you can see that we have now you can see that we have the resultant vector, which is a vector R, being given as that is axi, and plus that of bxi, that is the one thing, and plus AYJ and plus BYJ, and of which this represents that RXI, and this is RYJ, and in that case you can see this is the resultant vector, as you can see it there like that. So in this case that is how we find the resultant vector if we have it as that case. And at the end of the day, let's think of having the magnitude of the resultant vector R. Now the magnitude of the resultant vector R can be given as using the Pythagoras theorem, which is RXI square and plus RYJ that of square. And what is the direction? Direction is given as angle theta, which is given as the tan inverse of Ry divided by Rx. So that's how you should have to understand about all these cases, as you can see. And now let's say we have the following vectors. Let's say we have a vector, should be a vector A. Let's say a vector A is having the components given as, let's say 5, let's say a 5i plus, let's say, and that should be, let me have this. Let's say we have the vector A. A vector A, let's say it is given as 2 components. It has the x component, let's say Rx. Let's say should be Ax. Let's say Ax is given as 5 meters, and let's say we have Ry, which is, let's say, given as -2 meters. And assuming that we have the vector B with components given as Bx, which is equal to, let's say, 5m, and let's say By is given as, let's say, 10 meters. Let's say that is the case. Now, how should you have the magnitude of, how should you have the resultant vector for the summation of these 2 vectors using the component method? And also we should tell the direction, of the resultant vector if that is the case. So we understand that the magnitude of the resultant vector will be given as the square of Rx square plus Ry square. That will be the resultant vector, and of which the direction, which is the angle theta, will be given as the tan inverse of Ry divided by the Rx. And that much you should know. And how do you have to have all those components? So let's start with the Rx. So Rx consists of the summation of all components around x for the given actual vectors. We'll have it as Ax, should be Ax, and plus Bx. So we are to add those vectors componentry. So what is Rx? We have it as 5, and what is Bx? We have it as 5 as well, and which is in meters. Now we have it as 10 meters. So that is the Rx, as you can see it there. And how about, let's say, the Ry? So Ry also consists of the summation of these vectors complementary, and that is along y, and which is the same as, we have it as -2, and that should be that, and also plus, that is 10. It should be meters, which is the same as, we have it as 8 meters. So that's how you can see it like that. And the next from there is that we'll have, next from there we'll have the resultant vector, which is the square of, and what is Rx? We have it as 10. So 10 to the power 2 and plus, What is the RY? We have it as 8. So half to the power 8 should be to the power 2. And according to the principles behind, we have 10 to the power 2, which is the same as 100. Now have sort of 100 here, and the plus 8 to the power 2 is given as 64. So for each upon adding, we'll have it as 164. So that will be given as the 164, like that. And what is the square root of 164? And anyway, we can leave it in that way, square root of 64, or we can think of simplifying it further, since 164 it's not a perfect square. So square root of 164, that will be given as, should be 12.81. 12.81, that is in meters. So this is the actually a resultant vector upon having the summation of those two vectors. And what is the direction? Direction will be given as the tan inverse of, that is 8 divided by 10. That will be given as, so what is that? Now we should have to go for the tan inverse. Tan inverse of 8 divided by 10. That will be given as 38 point, let's say 7 degrees. So this is the direction of the resultant vector, as you can see there. Now, but let's say if we have two vectors, let's say we have the vector, let's say vector C, with components given as Cx, let's say is given as 0.5 meters, and let's say we have Cy, which is given as, let's say, 5 meters, and we have the another vector, which is vector D, with components, let's say dx being given as, let's say, 4 meters, and we have the another component, which is a component y, let me have it as 2 meters. Now let's think of having the magnitude of the resultant vector, which is a vector A, that corresponds to have the vector C plus the vector D. So now in this case, the resultant vector has been presented as a vector R, and that is obtained from the sum of these two vectors. Now how should you have it componentry? Now we should have to understand that the resultant vector, a vector A, which is the resultant, will be obtained upon having ax square plus ay square, and of which ax square will be obtained from the summation of the x components of those vectors, and also ay will also be obtained in the same way, like that. And how should you have what to get as the ax? So in this case, ax is given as 0.5 and plus 4. What is that one? We have it as 4.5 meters. And how about that of ay? You have it as 5 meters and plus 2 meters, which is the same as 7 meters. And of course, and how should you have the resultant? Using Pythagoras theorem, the resultant, which is a vector A, is given as, now have 4.5 power 2 and plus that of 7 to the power 2, and from there we have what is 4.5 and to the power 2. Now we have it as 20.25 and plus we have it as 49, which is in the square root, and we should have to actually sum up those, and that will be given as the resultant, which is a being given as, should be the square of 69.5 20.25. And how about the direction, which is the tan inverse of 7 over 4.5. So you'll be able to have the angle there in terms of what Intel is all about. But that's how you start to understand it on how we can add the vectors componentry. Let's say we have this case. So now let's see how we can handle this question. A vector A, by the way, I should have a vector A has a magnitude of actually 4.0 meters. So a vector A has the magnitude of 40.0 meters, and it points in a direction 20.0 degree below a positive x-axis. So which means if we can come up with the Cartesian plane, and this is, if I can come up with a Cartesian plane, it points about 20 degrees below positive x-axis. So this is how we should have it. So this is a vector A, and it is about 20 degrees below positive x-axis, like that. And a second vector, which is a vector B, has a magnitude of, so we have the vector B, which is having the magnitude of 75.0 meters, and it points in a direction 50 degrees above the positive x-axis. So this is the positive x-axis, which is a vector B, and it is above the positive x-axis with about 50 degrees, as you can see there. Now the question says that using the component method of the vector addition, find the magnitude and the direction of the vector C such that we have the summation of these two vectors like that. So which means the point of interest is that we should have the magnitude of the vector C using the Pythagoras theorem, which is cx square plus cy square, like that, and of which the direction should be given as the tan inverse of cy over cx according to the principles behind. So let's go ahead and see how we can have all this in that way. Now you can see that the vectors that have been given, they do not have their components, so it is our humble duty to deduce the components of these vectors. So let's start with the vector A. What are the components of the vector A? So a vector A, let's start by looking at its x component, that is ix. How should we have the x component of the vector A if that is the case? So mind you need to understand about how we resolve the vectors into components by this far, and in case you are much far away from vector resolution concept, just have to refer to my video playlist and come across with the vector resolution, where I understand all these things. And in case of other things, I also have to post the link in the comment section below. Just have to go through that. I'll post a link about the vector resolution in case you do not have the much idea about it. Now we should have to resolve the vector A into components, and of which this will be its x component, that is ax, and this will be its y component, that is ay, as you can see. And now in this case we'll have the angle is against x-axis. In that case it means ax It means that ax, we'll have it as, that is magnitude of the vector a, and it times the cos of, the cos of angle theta, which is 20 degrees. Now, since it is pointing towards the positive direction, it means this component will be positive component. So now in this case, we have, what is the magnitude of the vector a? So we have 40 times cos of angle 50, actually should be angle 20. That will be given as 37.6. So we have 37.6 meters. That is the x component of the vector a. And how about the y component of the vector a? So since the y component is pointing downwards, it will be negative. We'll have to indicate negative here. And we have it as 40. In that case, we'll have it as a negative, magnitude of the angle, the magnitude of the vector a times the sine theta, which is 20 degrees. So now in this case, we'll have, negative 40. Let me have this, negative 40, and times the sine of angle 20. That will be given as the negative. 13.7 meters. So that is the actually y component of the x. It should be y component of the actually vector a. That is, we have ax. Let me have this. That is, we have it as ax being given as 37.6, and ay we have it as 13. It should be negative 13. So we have negative 13.7, like that. And then we should also have to resolve the vector b into components. So how should you have it? No principle means the same. A vector b should also be resolved into components, in the sense that you'll have, this is its x component, that is bx, and this will be its y component, that is by, like that, and the angle is against the x-axis. And how should you have the x component, which is bx? So bx will be given as, since it is pointing towards the positive direction, we'll have it as the magnitude of the vector b times the cos theta, which is 50. So that is now being given as 75, times cos of 50. That is 48.2. So have it as 48.2, should be 48.2 meters. And how about what we get as the by? So the y component is pointing up, which is the positive direction. So Strumo have it as the magnitude of the vector b times the sine of theta, which is 50. So which means Strumo have it as 75, times the sine 50. That is 57.5. So we have 57.5 meters, like that. Now we have the full information. We should have to find the magnitude as well as the direction. So how should you have it there? Now what we can do is we'll have the magnitude, which is given as the square of, so by the way, we should have cx. So we have cx, that will be given as ax plus bx, and I will have cy, that is given as ay plus by. Then the magnitude of the resultant vector c will be given as cx square plus cy square. then you can be able to have the magnitude, and from there you have what you call as the direction, using the same principle behind. And now let's say we have this other question. An air traffic controller observes two airplanes that are approaching the airport. The displacement from the control tower to plane 1 is given by the tower A, which has a magnitude of 220 km and points in a direction 32 degrees north of west. So we have the magnitude of the vector A, which is given as 220 kilometers, like that. And we should have to come up with a Cartesian plane, which is, we should have to understand that we should have to come up with the cardinal points and depict. This is north, east, south, and west. And now the direction says that it points in a direction 32 degrees north of west. So which means the angle has to be measured from north towards this direction, towards north. I should say the angle has to be measured from, west towards north. That's how it will be. So now for that case, we can see that if we tend to see that as a Cartesian plane, this is how it will look. So it means we'll have that one. And now that particular angle will be in this quadrant, which is that of the second quadrant. So this is the vector A, and the angle is given as 32 degrees. We write that. And the displacement from the control tower to plane 2 is given by actually a vector B, which has a magnitude of, we have the vector B with a magnitude given as 140 kilometers, like that. And the points, and there should be, and the points 65 degrees east of north. So we understand that, this is east and this is north. Now for that case, what you can do is this is how it looks like. So this is vector B, like that, and this is an angle which is given as 65 degrees, like that. Now the question says that we should have the magnitude, which is the resultant in the direction of the vector D, such that we have that one. So at the end of the day, we need to have the magnitude of the vector D, which is the resultant. You can have that, which is the same as the square root of dx plus should be square and the dy square. We have that, and of which dx will be given as ax plus bx, and we'll have dy, which is the same as ay plus by, and the direction is tan inverse of dy over dx. So try to have that. And now let's say this is the question. The initial velocity of a car should be as a vector, which is a v1 has a magnitude of 45 kilometers per hour, of course in the positive x direction. So which means if we think of presenting this on the Cartesian plane, it means this particular direction, it means the direction it's along x-axis, which is the positive direction. So that is how it is, v1 and having the direction and being given as should be 45 kilometers per hour, and in that way. And the final velocity of the car, which is v, is about 66 kilometers per hour in the direction that points 75 degrees above the positive x-axis. So let's say this is 75 degrees, because this is the positive x-axis, and above that one we have actually a vector 2. So that is the vector 2, like that. Should be a vector vf, that is the final velocity, in that way. And now the question says that find the magnitude in the direction of the change in velocity, which is delta v. So delta v is the same as, vi plus vf. That's what it means there. So which means the magnitude of the delta v, has to be given as the square root of delta vx square plus delta vy square, and of which the direction, which is theta, will be given as the tan inverse of delta vy divided by the delta vx, and of which delta vx, you have to understand that this is the same as, v initial x and plus vfx, the way we have been doing that one. And the delta v should be delta vy will be the same as viy plus vfy. So you should have to resolve these into components. So you resolve this into components, and also this one into components as well. So let's see how we should have it there. So now in this case, what we'll have is let's think of having the x component of the v1. So v1x is given as 45 kilometers per hour. That is the x component, because the vector, the direction, is already in the positive x-axis. How about v1y will be 0 because the vector already in x-axis horizontally. And how about vfx? So vfx will be given as, so this vector will be resolved into components. And now since the angle is again is x-axis, and upon resolving that, we'll have this is x component and this will be y component, of which the x component is towards the positive direction. Hence we'll have it as a positive, and times positive should be positive 66. That is positive 66. That is the magnitude of the final velocity, by the way. Positive 66. Of course, that should be positive 66, and the times cos of an angle 75. So that will be given as 17.1, and we'll have vfy, that is the y component. So that will be given, since it is towards the positive direction, also have it as 66, the times sine of angle 75. That will be given as 63.8. We'll have that, and from there we'll be able to have, that one. So that's how you start to understand about how we can have the resultant vector as well as the direction using component method. Let's say we have this question: a vector A points in the positive x direction and has a magnitude of, we have a vector A with the magnitude given as 75 meters, and we have the sum of the two vectors vector A plus vector B, and having the magnitude of, now that is the magnitude of the vector C, that is equal to 75 meters. That should be 95. that is 95 meters, and it is about, in the positive y direction. So find the magnitude and the direction of the vector b. In other words, which to have the magnitude of the vector b, of which the formula will be given as bx square plus by square, and the direction has to be given as the tan inverse of by of bx. So how should you have all this? Here is the first thing you need to keep in mind about. We are being given that the vector a, points in the positive x direction. A vector a points in the positive x direction. So which means its x component is the same as 75, and its y component is given as L. And we have the vector c, that is the result of these two vectors upon adding the two vectors. So the vector c, has the magnitude of 95 meters, and of which you will have its components. We have cx, since it is pointing towards a positive y direction, we'll have the x component being 0, and cy is given as that of 95 meters, like that. But the reality is that a cx consists of ax plus bx, and of which we have the cx, which is 0, is equal to what is the ax, 75, and we have to solve for bx, of which bx will be given as negative 75, like that. And also using the same principle, cy is given as ay plus by. And what is ay? Ay will be given as, should be cy is equal to what is the ay? We have it as L. The plus what is by? By will be given as, so by is what we are looking for as that. But what is cy? We have it as 95. So cy is 95. We'll have it as 95 here. And what is the by? We'll have it as negative 95. Should be positive 95. So that is by. Then using this formula, we'll solve for the magnitude, and also using this one, solve for the direction. So that's how you can make it there.